to the sound. To the sound.
All right, let's get started. Welcome. It is that time of the year, the annual, I think. Well, I don't know what's annual. It could be per annual, it could be biannual, it could be whatever. I don't semi-annual. But anyways, it's time for that hangout again where we talk about our favorite equation, 0.99 repeating equals 1. Why? Because there are people coming around that just haven't gotten it yet. They don't understand it. And so I was like, you know what? We'll do it again. Hey, Tau Software. Hey, Tau Software, I got something for you. One sec. There you go. I got something for you. Take that, Tau. Take it whether you like it or not. I'm not going to ask your permission. I violated your consent, so deal with it. But anyways, there you go. So I'm going to be talking about basically what came from my blog when I wrote about this, and I wrote that the reasons why 0.99 repeating equals 1, and if you find somebody who doesn't believe it, what you can ask them. And if they can't answer these questions, then they probably don't really understand the material well enough to say that 0.99 repeating equals less than 1, because they're basically going by incredulity. And an argument from incredulity is not an argument. Well, at least not a rational one. It is fallacious. And so I'm going to be going point by point by the 4 things that I wrote to ask people if they deny this equality. I'm going on record. It is an equality. It is an objective fact. There is no subjective evaluation to it. If you think it's not correct, you're wrong. Period. There's no debate. There's no discussion. It is math. You're wrong. If you think you can prove objective fact is wrong, then just do so. Write your mathematical proof. But nobody's ever been able to do so. And every proof that has been attempted on this clearly has major errors, and any mathematician has been able to point them out, because I've only seen a handful of them, and they were silly. And the 1 or 2 that they thought they kind of knew, could get around it, there's still errors in their proofs. So good luck with that, because this is like trying to argue and prove that 0.5 is not equal to 1/2. That literally is the same thing. If you think you can prove that 1/2, the fraction 1/2, is equal to 0.5, good luck with that. Go ahead. You're not going to get anywhere. It's the same thing that you're going to run into when you try to prove that 0.99 repeating equals 1. But nobody can stop you from trying. In fact, I highly suggest trying, but you're going to end up failing. So, like I said, I'm going to go over like the 4 things that I came up with, the 4 statements that I came up with to test whether somebody, 1, has even understanding of the topic, or 2, can actually give an articulate argument of why the equality doesn't hold. Okay? And I'm not going on camera today. I'm very tired. I had to take a nap just recently, and I got some coffee, so I'm very, very tired, but I want to do this anyways. And so here we go. Let me get rid of this. And let me go here. Okay. So the first thing I wrote was this. And this is basically a relationship of what we mean by, and again, I'm not a mathematician. I did have some advanced maths. I did take calculus, but this was many, many, many decades ago. And I'm going back, years and years and years to draw upon my knowledge of the subject. I have done calc level videos. I have a series on calc 1 and 2, but if you ask me to do a integral of something, I'm probably going to go, what? It's going to be very complicated for me. I could probably do derivatives, but obviously. But, I think I still understand some of the concepts, but doing the actual integrations, that's beyond my level, because I don't know the formulas anymore. I don't know the rules. I would have to look it all up, but I understand what an integration is, obviously. So there's certain things in mathematics that they break things down into sets. And so the main set of all numbers on the real number 9 are called the reals. So when somebody says they're doing real analytics, that means they're doing mathematics with the real numbers. They're not using a constructivist approach. They're not making their own fields of numbers. They're not working with other numbers are not in the reals, like complex numbers, right? Reals are a subset of the complex plane. So all real numbers are complex, but not all complex numbers are real. And a lot of people have a hard time conceptualize that. But complex numbers are just the real numbers with an imaginary component. So if the imaginary component is 0, what do you get? You get a real number, right? So all real numbers are a complex number, just with the imaginary portion being 0. In the real numbers, you have different groups, different sets. You have the integers, which is designated by z. You have the positive integers, which is designated by z plus. You have the rationals, which is designated by q, because r is already taken for reals. So, and it stands for quotient, if I'm not mistaken. I think that's why they came up with q, because the quotient is p over q. So I'd assume that's why they came up with q. I've never really looked into that, but if you're a math guy up there, let me know. But I said all rational numbers, by definition, and this is a mathematical definition. This is not just a description from some sensu lato synchronic dictionary. This is by prescription. Okay, so in mathematics, there are prescribed definitions. And by prescribed definition, a rational number can be expressed in the form of a ratio of two integers, p over q. And in the set of q, p over q with the least common denominator of 1, where p and q are elements of z, meaning that they're both integers, where q does not equal 0. This means that q cannot be 0. That means that 0 in the denominator is undefined. This is why they say for a partial binary operator, which division is, you cannot divide by 0. Why? Because there's no definition for it. It is undefined. That's what they mean by undefined. It literally has no definition for it. Rational numbers have a definition. The ratio of p over q with the least common denominator being 1. Where p and q are both elements of z. They're both integers. Right? So 1 over 1 is 1. 2 over 2 is 1. 2 over 4 is 2. So, or 1/2. But those are still integers. Right? 4 over 2 is 2, which is an improper fraction. But they're all integers, and they're all where q does not equal 0. So you can have division. I can divide 2 into 4. I can divide 4 into 2. I can divide, 1 into 2. I can get 1/2, 0.5. But I can't divide 1 by 0. And again, the reason is it's undefined. And I disagree that math is descriptive. Math is descriptive, but there are prescriptions in math. There are 0, like for example, 0 factorial is defined to be 1 by definition. So there is, and the fundamental theorem of calculus 1 and 2 are prescriptive. So math describes, but there are things in math that are descriptive by definition. And they'll even say, even use a by definition symbol, which is a triangle over a equal sign. That's one way of doing it. Or you can use colon equals, but usually it's a triangle over equal sign. But that means by definition. So if you ever see triple bar, 3 lines, like an equal sign with 3 bars, that means by definition, which is stronger than just an equality. You see a triangle over equal sign, that's by definition. And that's prescriptive. So it's a little bit of both. Do you agree with that, Tal? Don't make me take your mod away, man. Look at this. I make a mod for one day on my channel here, and he's already, giving me crap. See this? This is what I expect from my mods. This is what I expect. This is what I'm making a mod for. Yeah, for the most part, it's descriptive. Sure, I agree with that. I mean, obviously, the whole point of calculus is to describe what we're observing when we see kinematics. When we see a parabolic path can be by mathematics predict where something's going to land. And yes, right, it describes the motion. Yeah, absolutely. Calculus is just basically, as Ken Hovind would say, scribbles on a page. They're just symbols that represent stuff. And that's true. It's descriptive. But in this particular case, it is prescribed that division in real analytics is defined by this particular formula here. And so, and this is going to be a pretty long hangout because, we're trying to get in the nitty gritty of this. So it's going to be at least an hour hangout, even though it probably could be done in 5 minutes, but you know me. But it goes on. I go on to say, since 0.9 repeating is rational by definition, as all repeating decimals are rational. I don't know anybody that's going to refute that. That's just common math. Rational numbers are repeating decimals are rational. All repeating decimals can be expressed in the form of p over q. This is a project that everybody in elementary school has probably done at one time. They just don't remember. But you take a number, any repeating decimal whatsoever, and you can use a very simple algorithm to convert it into fractional notation or non-repeating decimal. All of them. You can always convert it into a non-repeating decimal or fractional notation because it's a rational number. All of them. And I go on to say it has to be able to be expressed in the form of P over Q, where there's a ratio of two integers. If not 0.99 repeating is rational by definition, what is P over Q if 0.99 repeating? Well, there's actually an infinite amount of solutions to that, right? I mean, there's 1 over 1, 2 over 2, 3 over 3, 4 over 4. Any normalized value of 1, anything that equals 1, then it's going to satisfy P over Q, 0.5 over 0.5. Anytime you have P equals Q, anytime you have an identity there where P and Q are equal, you're going to have 0.999 repeating or 1, right? I mean, A over A is 1. No matter what A stands for, it's a unity, right? Everybody agree with that so far? That you have unity if you have 1 over 1? And so the challenge to the people that deny this equality is that they have to be able to come up with a P over Q that isn't that equals 0.9 repeating. And they in order to do that, they have to use integers, which is 1 over 1, 2 over 2. And P over Q, 1 over 1, is actually equal to 1. So any P over Q that they find that equals 0.99 repeating is also going to be equal to 1, every single one of them. Right? So that's the first one. All right, so let's take a vote out there. We got 10 math people out there so far. I want to see at least 5 people saying yes or no. Come on, you can do it. I got 2 mods out there. At least give me something here. And so I'm going to take Tao as yes. All right, moving on to the next one. 0.99 repeating equals the limit of k to infinity as a summation of n divided by 10 raised to the n, as n equals 1 to k by the definition of a limit of a sequence. Again, this is by definition. The limit of a sequence is defined. It actually also is defined that the limit of the sequence is defined to be the sequence upon which it converges upon. So f of x for s of n equals what is it? F of x of s of n equals s sub n. So basically, the limit of that, the limit of what it converges on equals the sequence. So if this particular sequence, and the way you would read this is basically the limit as k goes to infinity, which is going to be 1, 2, 3, all the way to infinity, and you instantiate n with 1, 2, 3, you start to get these what's called partial sums. And so every time you iterate this, every time you increase your value for k and n, you're going to get for k equals 1 this what's called partial sum that's going to give you 9 over 10 to the raised to the 1, which is equal to 0.9. For k equals 2, the same thing. The partial sum is going to be equal to the first partial sum, which is going to be of 1, which is 9 over raised to the 1, and then plus 9 over 10 raised to the second power, or 10 squared. And so you add those 2 partial sums together and you get 0.9 plus 0.09 equals 0.99. So you keep doing this, even like for k to the third, you get the same thing, right? 9 over 10 raised to the third plus 9 over 10 raised to the second plus 9 over raised to the 10 to the first gives you 0.9 plus 0.09 plus 0.009 equals 0.99. And so you repeat this for infinity, what do you get? You get all these partial sums that eventually will equal 0.99 repeating. Okay, so as k approaches the infinity, you have the value at 1, which it converges upon. And by definition, if a convergent sequence has a value it converges upon, that is, by definition, the limit of the sequence. And so that's what a partial sums would be. So for sums would be, or series would be 0.9 plus 0.09 plus 0.009 plus 0.0009 ad infinitum. And then you can stop that process at any time and you can get a value. And that's called a summation of partial sums. Now, a sequence is a little bit different, though. These are partial sums, but the sequence itself that's being formed from those partial sums is 0.9 plus not plus, but 0.9, comma 0.99, comma 0.999, comma 0.999. Those are the limits of the sequence that's going to form. So there's a little bit of difference. Actually, there's a substantial amount of difference between the limit of the partial sums of the summation and the limit of the sequence. The summation is the addition of the values that are produced by this particular formula. The sequence is the numbers that are produced by the partial sums. And so you don't add the sequences together. 0.9, 0.99, 0.999. You don't add those together. It's just telling you these are the final result of adding all these partial sums. And so if you start adding all these partial sums to infinity, and the end result from the first iteration is 0.9, and the second iteration is 0.99, and the third iteration is 0.999, what are you going to get after an infinite amount of iterations? 0.99 repeating. Right? So this is basically saying, if by the limit of the definition of a sequence, you're going to get 0.99 repeating, and by the limit of the partial sums, when you add all the sums together, it's going to equal 1, then 0.99 and 1 have to be the same thing, because the limit of the sequence by the 0.9, 0.99, 0.999 being 0.9 repeating is going to have to equal the limit of the partial sums, which is 0.9 plus 0.09 plus 0.009 to infinity. That's going to equal 1. The other one's going to equal 0.99 repeating. They are the same value. Boom. So you guys agree upon that so far? Are we good to go? Good. See, it's not that complicated. All right. Oh, did I change it? I didn't change it over, did I? Did I change it over? Did you guys see this second one? I'm sorry. I was talking about it, but I don't think I showed you. So there you go. Let me just run through this again. So 0.99 repeating equals limit of k to infinity, summation n divided by 10 raised to the n equals 1 to k by the definition of the limit of sequence. Limit k as k goes to infinity is a summation of 9 divided by 10 to the n equals 1 to k equals 1. If both 0.99 repeating and 1 equals limit to the k to infinity, summation 9 divided by 10 raised to the n equals 1 to k. Please explain how they're not equal. And I've already checked this in Wolfram Alpha way back when. I wrote this in 2018. November 2018. So 5 years ago, over 5 years ago, I wrote this, and nobody's been able to answer these questions and show me that they're not equal. Nobody. Not one person has been able to do it in 5 years. I wonder why. So anyways, that's how you read this. That's like I said, the limit of the sequence is going to be 0.99 repeating, but the summation of the partial sums of the limit being going from k to infinity is going to be 1. Therefore, 1 equals 0.99 repeating. And if you're a mathematician and I make a minor error, please, let me know in the comment section. It's been years, but I think I'm getting the general gist down. All right, next one. My roommate just called me a nerd. Did you hear her? Hey, you know what? I know where you live. Yeah. All right. I tried to do it funny. All right. So number 3, 1 minus 0.9 repeating equals x. What is x? Now, a lot of people have answered this way. This is why it doesn't make sense. I didn't have this happen in the Discord just last night. This is not a number. Infinitesimally small values are not allowed in R due to the Archimedean principle property. So given no infinitesimals can exist in R, please give the real value of x if x does not equal 0. If you claim x equals 0.000 then please construct 0.000 using the definition of a Cauchy sequence where the epsilon is greater than 0 and there exists n such that if m and n is greater than n, then the absolute value of am minus an, which is your sequence, is less than epsilon. And please give the sequence showing that it converges upon 0.000 Now, what this means is this. The Archimedean property states that there's no infinitesimals in R other than 0, or if you want to accept 0 as an infinitesimal. Some people do, some people don't. I don't really care. Makes no difference to me. If you want to consider 0 an infinitesimal, it works just fine. If you don't want to consider 0 an infinitesimal, it works just fine. It is your choice. There's no hard rule about it that I've ever seen in mathematics. So when they say Archimedean property, sometimes you'll see with the exception of 0. Sometimes you'll say no infinitesimal. It's really saying the same thing. I don't notice any difference. If you're a mathematician and you think there is if 0 is a infinitesimal or not, let me know. But I've read both, and to me, I don't care one way or another. If you want to consider an infinitesimal or you don't, it makes no difference. But the Archimedean principle says there's no infinitesimals, whether you accept 0 as an infinitesimal or not. So what that means is there's no value between 0.99 repeating and 1 that it can exist, because there's no infinitesimal between them. And because the reals are dense, for any rational number you pick, any two rational numbers you pick, you can always find a number between them. Always. You have x plus y divided by 2. You've got, for the rational, there's another formula too, I forget. But basically, for any two values, unequal values, you can find a number between them. And so this is saying that there's no infinitesimal value between those two. And the value that they say 0.001 dot 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 equals 1 is not a constructible number. All numbers are constructible for them to be real numbers. And the way one of the way they construct them is by either what's called Dedekind cuts, I didn't probably mispronounce that, Dedekind cuts, Dedekind, and the Cauchy sequence. And a Cauchy sequence is basically, it's really hard to explain, but basically a Cauchy sequence is saying that for every value you have and another value, there's some arbitrarily close number to that value approaching from the other value. So if I pick the number 1, there's always something arbitrarily close to that number 1 that I can go smaller in distance. There's no number that rests next to 1. There's no highest number that's next to 1. In other words, if somebody says, what's the closest number to 1 that isn't 1? It doesn't exist. There's no such thing. Because with a Cauchy sequence, you can always find a value in a sequence that's called complete, that you have the limit of that sequence inside that metric space. And I don't know enough about metric spaces to really get into them, but I do remember that for a Cauchy sequence, that the value of the limit of that has to be approaching the specific value. And if it's approaching a specific value, then it's considered to be what's called convergent. Okay, so that's what it means by constructing a value, constructing something by a Cauchy sequence. That you can construct this value by showing that there's this arbitrary closeness that you can get to a certain number, but you can always get closer. That's what it means by arbitrary. Any number you pick, you can always go more towards that number. There is no highest number next to 1 that isn't 1. Now somebody asks, would that mean 0.0001 is actually 0? No, of course not. These are dealing with infinite decimal expansions. 0.00000001 is a finite number. Well, they're all finite numbers. I shouldn't say that. 0.99 repeating is a finite number. Some people have said 0.99 repeating is an infinite number. No. It is not an infinite number. It is an infinite decimal expansion, but that's the notation. That's just the notation. The number itself is very, very finite. 0.99 repeating is literally on the real number line, equidistant on the range of 0 to 2. So if you go equidistant, midpoint on the range, 0 to 2, then right in the middle there, you're going to have 1. Right in the middle between, halfway exactly between 0 and 2 is 0.1. It should be, I shouldn't say 0.1, but the point that exists on the number 1, not 0.1, but 1 exists as a point halfway exactly distance, equidistance between 0 and 2. So it's a finite number. 0.99 repeating is equal to 1, so it's on the same exact point that 1 would be on the real number line. And remember, point has 0 dimensions to it. So we're talking about something that exists as a 0 dimension thing, right? A point. We're not talking about a point like a period or something like that. We're talking about a theoretical point on the real number line that this number exists. And so to construct this number 000.1, you have to figure out a way to do that using Cauchy sequences or some other method to construct. And there's no way to do it because you're saying that there's an infinite number of zeros in every single decimal place into infinity. If there's if zeros are in every single decimal place to infinity, what decimal place is 1 at then? There's no decimal place for 1 to exist. At least if you had all zeros, then every single decimal place is 0. So 0.000 ... is equal to 0. But 0.999 ... nines are in the every single decimal place to infinity. But if you have 0.00 dot dot dot, there's no place for that 1 to exist in any decimal place because every decimal place has already been occupied by 0 to infinity. So it's just what's called nan, not a number, nonsensical. 1 minus 0.99 repeating is equal to 0. They're the same number. All right, we good? Are we back on 1? I'm sorry. I'm showing you guys the wrong thing again. Why'd you guys tell me this? There we go. Is that better? I don't know why. I didn't know it switched. I have it on manual switching, so it shouldn't. But there you go. So, yeah, number 3, 1 minus 0.99 repeating equals x. What is x? Infinitesimally small values are not allowed in R due to the Archimedean property. So, given no infinitesimals can exist in R, please give a real value. There you go. Okay? And so you'd have to be able to construct this number. Until I see somebody construct this number, 0.00 dot 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 1, you have no argument. And I can tell you right now, it's non-constructible, at least using real analytics. If you want to try to make up some your own math, whatever, but that's not real analytics. You know, you can construct anything you want using your own mathematics. That's constructivist approach. But in real mathematics, you learn from elementary school all the way to college, 1 minus 0.99 repeating is equal to 0. All right, next one. By the trichotomy property, you can only have x is less than y, x is equal to y, or x is greater than y. There are no other options. That's why it's called a trichotomy. They're all mutually exclusive and jointly exhaustive. If x does not equal y, then there exists x plus y divided by 2 between them. Else as the reals are dense, else x equals y. Because the reals are dense, x equals y, and x equals 1 and y equals 0.99 repeating, then what is x over y divided by 2? Since as the reals are dense and there is no value between them, they must be equal. To say that 0.99 repeating is less than 1, you need to come up with a value of x plus y divided by 2. And 0.000 dot 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 1 is not a number. We've already established that. It's not constructible. So what number exists between 1 minus 0.99 repeating? It is literally the same thing as asking 1 plus 1 divided by 2, which is 2 divided by 2, which is 1. If you cannot tell me what number exists that actually is a number, which is clearly not 0.000 dot 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 1, what number exists between them? If not, they have to be equal. Just like there's no number between 1/2 and 0.5. 1/2 is called fractional notation. 0.5 is called terminating decimal notation. They're just two ways of representing the same exact value on the real number line. 1 is a terminating decimal notation. 1.0 is a terminating decimal notation. 1.000000000 is terminating decimal notation. 1.000 dot 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 is infinite decimal expansion, but it still equals to 1. Same as 0.99 repeating is a decimal expansion, infinite decimal expansion, which is just another symbol that represents the number 1. There's many different ways to represent numerically in a numeral a specific value on the real number line. If I say sine 90, that means 1. Sine 90 is a number. It's a value. It's a numeral. It's well, not necessarily a numeral, but it represents a value, and that value is 1. You can argue it's a number if you want. And so what we mean by numbers is a location on the real number line, right? So in number theory, if you really look into it, all they're really concerned about what is the value it's pointing to on the real number line. These are just symbols. They have a reference and they have a referent. 1, the symbol 1 represents the position on the real number line. Like I said, there's equidistance between 0 and 2 on that range. So the symbol 0.99 repeating is just a symbol that tells you that it is located on the same position that 1 is located. They're the same exact number, just a different type of representation, because you can construct numbers differently. And one way to construct the number 1 is by using a Cauchy sequence. And by using a Cauchy sequence, you're going to get this 0.99 repeating, which by the definition of a limit of a sequence is equal to 1. This is how mathematics works. Now, if somebody wants to like deny mathematics, that's perfectly fine, but this is objective fact that anybody can go review, anybody can go put in Wolfram Alfram, anybody can go use GPT chat, use 4.0, I guess, because it is better. I was playing with 3.0 and man, it's got some issues. It's good for like very kind of quick stuff maybe, but I can tell you right now, GPT chat, or chat GPT 3.5, oh my goodness, it is definitely not something you want to use for reference if you're writing a paper or something like that, except for very quick, simple stuff. Any kind of technical stuff, it's going to get the wrong answer. I'm telling you right now. I mean, you could train it on a session to get the right answer, but what good is that? I mean, sure, if you want to use it to help you write and you know the subject well enough where you can train it and do it, sure, it's fine for that. And people do use it for that. But I'm telling you right now, if you just go to chat GPT and type something in, you may not get the right answers. Do not take it as authoritative, because it's certainly not. So, all right. So that's my little spiel on why 0.99 repeating equals 1. If you got questions, put it in the comment section, because I'm going to end this because I want it pretty short, so it's easily digestible. It's only 30 minutes. Cool. All right, guys. Thanks for watching. I've now established why 0.99 I am tongue-tied. 0.99 repeating equals 1 for the umpteenth time over the last God knows how many years. I'm doing it every year probably because there's always new people coming around that think they know basic math. They think they understand calculus, but all they really have is an argument for incredulity. And the same lack of critical thinking they have when it comes to mathematics is the same lack of critical thinking they have with other subjects. That extends to things like evolutionary theory. That extends to things like astrophysics and Big Bang cosmology. And that extends to even religious beliefs. So this is why I really do hold firm to this particular formula, because if people are going to argue objectively or things that objective facts are wrong, how can you trust them in anything else? I mean, if you're going to tell me that X does not equals X, the law of identity, how am I going to trust you in anything else you have to say to me? Because you've already violated basic classical logic. You've already violated ingredients for rationality. And so I find that it's very funny because the most of the people that deny this equality also deny scientific facts, like the age of the earth, the age of the universe, evolutionary theory. And so, yes, I'm tying it into that because that's what this channel is about. This is not just a math video. This is actually tying it into critical thinking. If you do not accept the equality, 0.99 repeating equals 1, then I really just can't think to myself that this person that denying it is much of a critical thinker, because they haven't gone and objectively looked at the math, and they have not taken the time to try to disprove the math, because it is something that they cannot do. I've seen it for years. People tried, they've all failed. But if you think you can, go for it. That's how you learn. And then we realize, you know what? Maybe that you have the epistemic error. Maybe you have the false belief. And if you're willing to concede that you have a false belief on something that is objective as this, maybe you have a false belief on other things that you think you know about that you don't, such as evolutionary theory. Good night, guys.